Alright guys, so today's lesson will be taking it back to 2D shapes. We're going to look at the properties of parallelograms and rectangles. A parallelogram is a four-sided polygon where both pairs of opposite sides are parallel to each other. And the symbol for parallel is this weird little triangle symbol. So it's just stating that this side is parallel to this side, and these two sides are parallel to each other, and so to differentiate we would use multiple ones like 2. Now there are some special types of parallelograms, and I realize sometimes when I print things off they don't print off like they should, but special types of parallelograms would be the square, the rhombus, and the rectangle. And the big thing we're going to talk about today by the end of the day is the rectangle. But to not get into too much information, there are some properties you're going to need to know, and eventually we're going to solve for variables today. So the first property of parallelograms you need to know is that opposite sides are congruent. So let's say we gave this a name, like let's call this A, B, C, D, just for sake of today's lesson. Opposite sides are congruent means like if this piece here has to equal this piece here. They do look the same. So AB is congruent to DC. On the other side, AD would be equal to BC in all cases. So side AD is congruent to BC. Another weird statement is that opposite angles are also congruent. So once again, if I call this A, I'm just going to use A, B, C, D for the examples. So opposite angles are the angles that are completely opposite each other. So this looks bigger than 90, it's obtuse, and the other angle that looks bigger than 90 would be C. And if we actually measure them, angle A is congruent to angle C, and also angle B is congruent to angle D. It just means they're the same size. Now the weird statement is that diagonals bisect each other, and we talked about this with rhombuses at the first of the chapter. But the reason a rhombi are bisected is because of this property here. So, and I'm just going to add an E here just to make it easier to show. But these two pieces are equal to each other, and these two pieces are equal to each other. So AE is congruent to EC, and then DE would be congruent to EB. Alright, so there's a consequence to some of these. I'm actually going to go through the last one first, as all the angles add up to be 360 degrees. So if I did A, B, C, D and added all these angles up, the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D would be equal to 360 degrees. It's almost like it's a circle, but think about it from this standpoint. If we cut this in half, that's two triangles. You learn that a triangle adds up to 180, so two triangles together should add up to 360. Same side angles add to 180. So I don't want to go through every single instance of, I was calling this C as a beautiful C, and this is, Mr. Taylor is going to try to fix this in a second. Alright, beautiful fixing, but it's pretty much saying if you took two angles on the same side, like A and B, those are same side angles. B and C are same side angles. D and C are same side angles. And these are same side angles. These would add up to 180 degrees in all directions. And that might make more sense once we get to the last part of today's assignment. So these are equaling to 180. And we're going to now jump to examples. So the way the work will look today is find the value of each variable in each parallelogram. Now, some problems you won't need to show a ton of work, some problems you do. But using the properties we just went over, we can figure out information. So in this picture, we have x, y, 10, and 20. So information we can figure out from a properties list that will help us in this problem is opposite sides are congruent, which means this piece is equal to this piece. So I could say y equals 20. Y is by itself, 20 is by itself. That's half the problem. We can say this side is equal to this side. X would equal 10, and we are done with this problem. We've solved for x, we've solved for y. Some problems may be as simple as that, so that's what the properties we're going to use. Now, some problems might be a little bit more difficult. This is 4n if you have a hard time reading it, but we were going to have to figure out what information we kind of know. And we know that opposite sides are the same length. So we know 4n is equal to 12. And at this point in the problem, we can solve for n by dividing both sides by 4. So we would get n is equal to 3. So on the same note here, we know this side should equal this side. So we will set up 2x plus 1 is equal to 8. We'll subtract 1 from each side. And you will have 2x is equal to 7. And then we will divide both sides by 2. So x would equal 7 divided by 2 is 3.5. And we have the two variables in the problem solved for. Then problems may get a little trickier. First thing, we've got to solve for y. Now we know opposite sides are equal to each other. So we could do y plus 6 is equal to 10. And then to solve the equation here, we subtract 6 from both sides, and we would have y is equal to 4. And we've got the y solved for. Now the second property we covered is that opposite angles are congruent. So this angle here is congruent to this angle here. So we can set up that x plus 20 is equal to 100. And then solve this equation. X is equal to 80. And we're done with that problem. So you have to, the equations are not super difficult. It's setting up the equation and trying to figure out where do I start. So we'll go to something that might be easier to some other people. Find the measure of the indicated angle. Now, if we're wanting to find the measure of angle B here, there's multiple ways we can do this. But the way I have earlier is, since these are on the same side, if we added these together, they should equal 180 degrees. So if I set up the measure of angle A plus the measure of angle B is equal to 180 degrees, then I'll just plug in the 60 degrees for the A, and then I don't know what the heck B is, but I know if I add them together, there's 180. I could then subtract 60 from both sides. And then we'd have the measure of angle B is equal to 120 degrees. That's supposed to be a little angle symbol. What I have seen students do in the past is they'll know this is 60 and that's 60, so they'll do 360 minus 60 to get 300. And then, oh, I'm sorry. So what I've seen students do, I just said it wrong. So I have seen students do this before, where they know the whole thing's 360, and they subtract two 60s because they know these are both 60, and know these two are the same, so they would divide by 2 and get 120. That also works. But this way is the formula form. For number 5 here, finding the measure of angle D, it's pretty much the same way. I know if I add these together, they're going to equal 180. So the measure of angle A plus the measure of angle D is going to equal 180 degrees. So I'm going to substitute angle A with 80 degrees, substitute angle D with just the measure of angle D, and together they're going to add up to 180. So to finish solving the problem, I'm going to subtract 80 from both sides, and then we would have the measure of angle D is equal to 100 degrees. Now, before anyone asks, as long as you show me what you do, some people hates the equations way. I am fine with that. If you literally type in 180 minus 80, show me that work of whatever you type in the calculator. I want to see how you think. And then this will lead us to the last type of problem we will do with the parallelogram today. So find the measure of each variable in the parallelogram, and the last property we talked about with parallelograms is that the diagonals cut each other in half. So based off that logic, this piece is equal to this piece, so we could set up x plus 2 is equal to 15. And we could go ahead and solve this and subtract 2 from both sides. And we would end up with x is equal to 13. And the other thing we have is that this piece should be equal to this piece. So we can set up 3y minus 1 is equal to 12. Then do a two-step equation. We're going to first add 1 to both sides. And we will end up with 3y is equal to 13. Then we'll divide both sides by 3, and I'm fine with rounding to a decimal place today. So y will be approximately 4.3. This is where you might want to pause the video and take a break and do the first set of problems, the first 12 actually, or however many before you get to the bottom section that says rectangle. But I'm going to go ahead and move on and just make this one long video. So the next type that you will need to know for the exam will be properties of rectangles. You actually will need to know for it. So the other thing is the diagonals of rectangles are congruent. So if I label this A, B, C, D, not only do these bisect each other, but we also know that AC is congruent to BD. The whole thing is the same. If I took a ruler, these two pieces are exactly the same. The other piece most of you guys probably already knew, but I'm just throwing it out there again, is that all four angles make right angles. So that's just for, it's not really on today's lesson, but that's just something you kind of know. So what we're going to do on these two examples is find the length of each diagonal in rectangle ABCD. So normally when you draw a shape, you go in order of how it's written, like you would write ABCD or ABCD, but we're told that the length of AC, and there's my beautiful diagonal that I can't even connect two dots together, is 5x minus 2, and then this piece BD is 4x plus 1. But the rule is, since diagonals are the same, AC is congruent to BD. So in order to solve these types of problems, we have to set it up as like 5x minus 2 is equal to 4x plus 1, because we're given that information. So we'll solve an equation, so we'll need to kill off the 4x here, kill off the 4x here, then we would be set with x minus 2 is equal to 1. Then what we'll do next is add 2 to both sides. And we would have x is equal to 3, which is good now, but that is not what the question is asking us to find. It's asking us to find the measure of each diagonal in the rectangle. So now that we have x is equal to 3, and we were told that AC is equal to 5x minus 2, we'll plug in the 3 for the x. So this would be 15 minus 2, so we know that AC is equal to 13. Well, I'm going to double check my answer, because if I did everything right, this should be the same. So BD is equal to 4x plus 1. So we will do 4 times 3 plus 1. That'd be 12 plus 1. So BD is equal to 13. And since these are the same, I did the question right, because it is a rectangle. So last example of the day, and tomorrow we're going to start off with more advanced rectangle questions. As I said, today we're doing the basics, and then tomorrow we're going to start off with, okay guys, have fun. But AC and BD are the diagonals, and we know that AC is congruent to BD. Now on the homework, I'm using XY, W, X, Y, Z. Same concept. Draw the picture to get the idea, and then list it out. So we're going to have 3x plus 6 is equal to 7x plus 26. So the idea here is I'm going to get rid of 3 x's from both sides, because I like keeping my x's positive. So we will have 6 is equal to 4x plus 26. And we're going to talk about how bad this question is after we're done. We're going to subtract 26 from both sides. And this makes me sad, because we'll have 6 minus 26 is negative 20 would equal 4x. And we'll divide both of these by 4. And we'll have x is equal to negative 5, which is not wrong, but we're supposed to find the length of the diagonals. So for AC, we'll have 3x plus 6, and this would be 3 times negative 5 plus 6, which would be negative 15 plus 6, which ends up being negative 9. Now checking this again, we have BD is equal to 7x plus 26. So if I did 7 times negative 5 plus 26, that would be negative 35 plus 26. We would get negative 9. Now, even though this is correct, this is something I would call a bad question. And the reason is, length can't be negative. So if this occurs in the homework, let me know, but this is not a true rectangle. But that's still how you would do the work on these problems. Anyway, finish the homework and have a wonderful afternoon.